Are we good with it?
Yeah, we finished the first sample.
Okay, so the only thing that's different with the 2 sample is I made my students write down R-I-N like this, and then they put 1 sample here, or population or whatever, and then the other one over here. And so you have to check for both. And then the catch is, with the I, it needs 3 arrows. So you're doing everything the same. So the R is still random, I is still 10N is less than capital N. N is still NP is greater than or equal to 10, and N times 1 minus P is greater than or equal to 10. This third arrow, Bill, you have to say the 2 popular samples.
Yeah, yes, test for independence.
You just have to say are independent of each other, yeah. So, but you also have to do the 10N, right? So that's the only catch there.
Oh, and then what is that? They're independent of each other. How do you check that?
You just have to say it. So you say my 3rd hour is independent of my 4th hour. How they do on a test doesn't affect how 4th hour does, right? Unless it's cheating. Yeah. Are we good on Z interval / Z test? And again, for that N, just remember ZAP tax, and that's how you remember the NP versus for the T interval. Okay, so the Z interval for the do, just a friendly reminder, on your formula sheet, I don't know if you guys get test anxiety, but if you get test anxiety, the general formula for a confidence interval is on the formula sheet, okay? So stat plus or minus the critical value, will say, times the standard deviation. Do any of you have your formula sheet handy? It's okay, if you don't, just, oh, you do, Sam. So remember, you have it right here, right? And just remember, okay, you're like, wait, what standard deviation am I using? All the standard deviations are on page 5 right there. So you can pick from there, you can say, what am I dealing with, 1 sample or 2? And you're allowed this, yes. You can't bring your own, though, they'll give you a new one. So everything's right there. So if I'm on a Z interval, you have to think, am I dealing with 1 sample or 2? If I'm dealing with 1, I have a P hat. How do I remember it's P again? Because it's ZAP. Okay? If I'm dealing with 2 samples, right? So 1 sample is a P hat, 2 samples would be P hat of 1 minus P hat of 2. Plus or minus Z star, and then go to your formula sheet, right? Go to your formula sheet for the standard error. Questions there? Does that help? Yeah. Okay. The next one then would be the Z test do. And when I say do, I mean the state plan do, right? For the do part with the Z test, just think, hey, I'm dealing with a normal curve. Did Mr. Dance make you draw the curve? I think the curve is really helpful, and the main thing I tell my kids is it's the insurance policy. If you're on the edge, because it's out of 4 points, each free response question is out of 4 points. If you're on the edge between a 3 and a 4, they'll bump you up to the 4 if they see you have your picture laid out nicely. Now, if you're not used to doing it, don't try to cram and learn it the night before. My class, I expect it on everything, so I think they should be good. But in the middle is my parameter. That's my mean, okay? So that's going to be your P, or it's going to be 0. It's 0 if it's 2 samples. Okay? It's 0 if it's 2 samples. Why is that? Because we always assume that the difference in proportions is the same. There's no difference. Okay? And then here's our given, whatever the given P is. That's your probability that we were talking about earlier. Like, half the times I should flip heads, right? Then you're going to mark your statistic, wherever that will be. And your statistic's either going to be P hat, or the P hat of 1 minus P hat of 2. You're going to mark your standard deviation. And that's going to come from your formula sheet on page 5, right? Okay? So I won't take the time to write that out. You can look that up. Do you have any questions while you're looking at it, Cam? So you're going to say one sample or two, am I dealing with P's or X bars, and then you're going to go to where it is on the chart. And then finally you need your Z score. And that's your statistic, your observation, minus your mean, your center, right? This is my mean. Divided by that standard deviation. And I always tell my kids, as long as you plug in the values up here, don't rewrite it down here because the calculator will take everything out for you. In the calculator, the command you use is a one-prop z-test. Okay, so make sure you can find that in your tests. It's going to be a one-prop z-test or a two-prop z-test. One-prop z-test is 5. Two-prop z-test is 6 in your calculator. Okay, I'll give you a second to look for that if you want. So you're either using a one-prop z-test or a two-prop z-test. Make sure if you're watching this or listening right now that you do not use the z-test or the and then there's the one-prop z interval and the two-prop z interval as well. So always the one props for those. Don't use the other ones. That's a big thing that I'm a little worried about for people. Does that make sense? Okay. All right, let's move on. The t interval or t-test, okay? RIN, so R is still random. I is still the 10N rule, and this time, for the N, if it's not, what do you have to do? Yeah, I think the fastest thing to do is to draw a dot line. Okay, so you draw your dot plot. If N is less than 15, it needs to be pretty symmetric. And I always tell my kids to use the word symmetric enough so you can proceed. If it's between 15 and 30, it can be skewed. But there should really be no outliers, okay? So we can have it skewed, but no outliers. And then if it's above 30, we don't care. And why is that? Do you guys remember? The central limit theorem, yeah, because of the central limit theorem. Now, there's one catch. If it states it's normal in the problem, we don't even have to worry about any of this. We can just state, instead of even showing that n is greater than 30, if it comes from a normal parent population, we're good to go. Questions there? Okay. Now, RIN, again, 2. And then just make sure that third arrow would be the two populations are independent of each other. Can I move on, or are we good? All right. T interval, do. So the do step of a T interval. Do you want me to go through it? And again, if you have to leave, I know Jackie said you have to leave early. Just bug out. Do you want me to go through the T interval do? Yep, okay. So for the T interval do, again, you go to your formula sheet, right? You have that statistic. So hopefully if you're watching at home, you're looking at your formula sheet on page 5, plus or minus your T star times the standard deviation and the standard error. Your statistic, you think, what am I dealing with? Am I dealing with a 1 sample or a 2 sample? If it's a 1 sample, I have a T. I know it's a T because of tax. So I have X bar. If it's a 2 sample, it's X bar 1 minus X bar 2. Plus or minus T star times the standard error. Where does the standard error come from? Again, you go to your page 5 and you look at, I'm dealing with means now, so it's either one sample one or the two sample one, and you plug your values in. Okay? Now there's one thing here, how do you find your T-star? Do you guys need help remembering how to do that? You go on your table and you have to look at your degrees of freedom. It's n minus 1. Okay? It's n minus 1 for one sample. For two samples, the calculator will give you the degrees of freedom. And what I've instructed my kids to do is you're just going to be plugging in all your values, right? So on a two sample, if I give you an example, and I said the average AP score for hour 3 was a 4, and the average for hour 5 was a 2, okay? And I come in and I say my n here is 30 and my n here is 35, right? If I'm gonna do an interval, I'm gonna put it right in the calculator. So why don't you do that now, okay? So go to your two sample t interval. And now, am I given data here or am I given statistics? I'm given data. What is statistics? Statistics is where you have to enter it in your list, okay? I'm sorry, other way around. Data is where you have to enter it in your list. Okay, so I'm gonna say, hey, my mean is 4, and I'm gonna give you a standard deviation of 1 here. And here I'm gonna give you a standard deviation of, actually, let's say 0.1 and 0.2. Okay, so I'm entering 4, I'm entering 0.1, my sample size is 30, I'm entering 2, my standard deviation is 0.2, and this is all, I know someone's gonna watch this and say, where is she getting this data? I'm just making this up, we're practicing the calculator. I'm getting a 95% confidence interval, am I fooling it? No, we're not fooling it, we calculate, we get our lower bound and our upper bound. So my lower bound is 1.9229. My upper bound is 2.0771. What do they expect on the exam? They expect you for the interval to show me 4 minus 2, right? Plus or minus T star for degrees of freedom of 51.5811. Is that T star going to be on your chart? It won't be. If you look for the degrees of freedom right now on your chart, make sure you know how to use that chart. If you don't know how to use that chart, make sure you ask. It won't have that, so you just leave it blank, okay? And then you go to your standard error, and you take that standard deviation 0.1 squared over n plus 0.2 squared over n, and you take the square root of it out. Okay? And that's all you have to do to show your work. So you have the formula all plugged in. Your T star for a 2 sample, you're not going to be able to find. Okay? Well, you can find it using your calculator, but Mr. James and I have not taught you that. So just leave it blank. And the reason you don't want to estimate it, sometimes people will teach you to estimate it. I'd have to round down to 50. Well, I'm going to have a different T star here. And those mathematics, if I type it in, don't match up to my calculator. Does that make sense what I'm trying to say? So just leave it as is, and they'll be fine with you just rounding like that. I'm sorry, they'll be fine with you leaving it blank. Okay? Questions there? And that's all the work you have to show for a T interval, for a 2 sample T interval. Questions? Okay. For a T test, what do you really need? You're going to be plugging everything in, right? But if you want to know, like on the curve, my parameter will either be the given mu, okay, or 0. It's going to be 0 if it's a 2 sample. You mark your x bar of 1 minus x bar of 2. You have your standard deviation, whatever that may be, if it's 1 sample or 2 samples. So this is for 2, this is for 1, right? You get your t-score, your observation, so your x bars minus your mean divided by your standard deviation. And then everything else will pop out on there for your calculator. Some people in my class were practicing these problems and they were just giving me the t-score, what it was, and you do need to show your work. So you have to say, what is the observation? So that's either going to be your statistic, your x bar minus 1, x bar of 1 minus x bar of 2, or just your x bar, depending on what sample it is. I feel like I'm going really fast spitting information out. Are you okay? Okay. Minus your mean, so the center, divided by the standard error. Questions there?
So that little box is just for the
Yep, exactly. Whatever that little box is the statistic. So it's either going to be x bar if it's a 1 sample, or it's going to be x bar of 1 minus x bar of 2 if it's a 2 sample. And then your p-value will pop out, and then you have to compare it to alpha. The conclusion is the same for every single test. You want to go through the conclusion? Okay, so if alpha, or let's start with your p-value. If your p-value is less than alpha, what do? Remember? We reject our null hypotheses. We have evidence for HA. If our p-value is greater than alpha, we fail to reject. We have no evidence for HA.
You need 2 sentences. So the first sentence would be right here. Because my p-value is less than alpha, I reject H naught, period. The second sentence right here, I have evidence for HA. The HA has to be in context. So that's telling the story. What is your HA in a sentence? Some people struggle with context. Always use the question to help you with it. There's professional writers writing these questions. So use their wording, like plagiarize pieces of their question, right? If they're saying the proportion of people going to the U of M and studying science, just copy down what they have. I found that the proportion of people going to the U of M and studying science is greater than 0.5, okay? So that will be really helpful for you. Questions? Okay, and then we have our chi-squareds finally. Okay, you remember chi-squared? I like chi-square because there's not much you have to show, right? So you have your 3 methods, and then you just have to show what the chi-squared value is, a little bit of work, and the p-value. So we'll finish this up, Sam, and then we'll be done.
Yeah.
Sound good? Okay, so goodness of fit is for 1 sample, 1 variable.
This could be like the color of M&Ms, right?
Yeah.
Blue, green, red, purple.
But the sample is just the inputs.
The sample size is the M&Ms. So you say, oh, I get 10, 30, 20, and 5. And then the candy bar company says, but it should be this percentage. And so you check and see if the goodness of fit test. Okay? Independence, that's for 1 sample.
And these are significance tests.
These are also significance tests, yes. So you want to ask yourself, I have 1 sample, 1 variable, it's goodness of fit. So my variable up here would be the M&M color, right?
Yep.
Independence would be 1 sample and 2 variables. So I could say, a lot of times it's gender, so it's like boys, girls, right? And it could say, driving a red car, driving a black car. We want to see if gender is independent of the color of car you drive.
But it just takes from a random sample of this
Yep, so it would say, hey, I'm going to interview a sample of 100 people, and I asked them 2 questions. I said, what's your gender, and what color car do you drive? And I recorded the info, okay? Now, homogeneity, homo is that prefix that means same. Okay, so that would be, let's say I have AP stat scores for the last 5 years. So I would say I have the year 2016, 2015, 2014. Let's do 3 because I don't want to write down all the numbers, right? And I'm going to look at the distribution of the people who passed. So 5, 4, 3. So this is 3 separate samples with 1 variable, right? The variable is their AP test score with 3 separate samples, okay? So it'd be 2 plus samples and 1 variable. So the variable here is the test score, and then my samples are the 3 separate samples of AP classes. And I'm trying to see right now, I'm investigating if it's the same across the board. And the thing I like about independence and homogeneity, it's just entering the matrix into your calculator, running it, you get that chi-squared value and that p-value, okay? And there's a little more to it, but that's just like the basics of it right now. Questions?
Yeah, I'm just gonna get down to this.
Okay. No, that's good. While you're doing that, I'll write down the conditions on the side. I don't know what acronym Mr. Jans uses. I use RICE. And that's all I have. So I'm going to pause it